Today's lesson objectives: students will identify congruent figures and write congruent statements for polygons. So first of all, congruent figures. What do I mean by that? Well, we know that congruent angles have the same measures, congruent segments have the same measures. Well, congruent figures are figures that are made up of angles and segments that are congruent to each other. So all the parts of one figure are congruent to the corresponding parts of the other figure. When you write a congruence statement, you must list the vertices in the same order. In other words, the corresponding vertices need to have the corresponding position in the congruent statement. So, for instance, let's first talk about what our corresponding sides are in these figures, these two triangles. I can see that AB is congruent to FE, so those are corresponding to each other. Segment AB is congruent to segment FE. Likewise, I can see that AC is congruent to FD, so those correspond. And finally, BC is congruent to ED. My corresponding angles: angle A is congruent to angle F, angle B is congruent to angle E, and angle C is congruent to angle D. So now when I write my congruence statement, I see that A and F should be in the same position, B and E, and C and D. So what I mean by that is I can say triangle ABC is congruent to triangle FED, because in my figure, A corresponds to F, B corresponds to E, and finally C corresponds to D. So now I don't have to call that triangle ABC. I could call it triangle BCA. And if I did that, I would have to say triangle BCA is congruent to triangle EDF, because again, B goes with E, C goes with D, A goes with F. And so when you see a problem on your assignment that asks for a congruence statement, that's what these are. These are congruence statements right here for the figures. All right, so for example 1, I have that QRST is congruent to WXYZ. So the first thing it says to do is identify all the pairs of congruent corresponding parts. So just like the triangles, we'll do that again. So we've got corresponding sides, and then we have corresponding angles. Well, the angles are the easiest ones because we can go through and just look at the congruent statement. Q is congruent to W because those are the two that came first in the congruent statement. So angle Q is congruent to angle W. And then I can say that R is congruent to X. Angle R is congruent to angle X. S is congruent to Y. And then finally, angle T is congruent to angle Z. Now, when I look at the figures, I can see that one of them is twisted relative to the other because Q is over here and W is on this side. And so sometimes it's hard to visualize it when they're not facing the same way. So actually what I'm going to do is I'm not going to write the sides there. I'm going to redraw the figure first so that it's in the same position as the first one. I'm going to redraw WXYZ. So since Q and W correspond, I know the W would be here, and the X would be here, the Y would be there, and then the Z. And so now it's going to be easier to list my sides that are congruent. So let's put them over here. All right, so now I can see that QR is congruent to WX, as you can see them in corresponding positions. RS is congruent to XY. Oops. And then ST is congruent to YZ. And QT is congruent to WZ. So those are my corresponding angles and sides. Now I have to find the value of X and Y. So I'm going to transfer the information into my new figure. That was from the old one. So I see angle W is 5x plus 5, so I'm going to put my 5x plus 5 with angle W. And then I see that WX here was Y minus X, so that belongs right here on my new figure. So I can first figure out X by using the 65 and the 5x plus 5. Because they're congruent angles, I know they have to be equal to each other. So 5x plus 5 equals 65. If you subtract 5 from both sides, I get that 5x is equal to 60. And then divided by 5, I get that x is equal to 12. Then I can solve for y, because I know y minus x has to equal 6. Because here's my 6 and my y minus x. And now I can plug in the x, which was 12. Add 12 to both sides, and I get that y is equal to 18. Okay, so looking at another example. I know that DEFG is congruent to SPQR, and I want to find the value of X and Y. So let's start with X. I have 2x minus 4 feet, and that's on QR, which is right here in my congruent statement. So QR is going to correspond to FG. So that means the 2x minus 4 is going to equal to 12 feet. And again, you can redraw the figures if that helps you see it, or you can use the congruent statement to figure out what corresponds. But based on the congruent statement, I know that FG has to be congruent to QR. And so therefore, 12 feet has to equal the 2x minus 4. And then I can solve for x. If I add 4 to both sides, I get that 16 is equal to 2x. And then dividing by 2, x is equal to 8. Now I can do a similar thing for y. For y, I've got angle Q, which is right here in the congruent statement, so that is going to correspond to angle F right here. So my 6y plus x is going to have to equal 68 degrees, because angle Q is congruent to angle F. So 6y plus x is going to equal 68. I found that x was 8, so I'll go ahead and put that in. And then I subtract the 8 from both sides, and I get 6y is equal to 60. And so y is equal to 10. And that concludes this video. Thank you.